So now what we're going to do is talk a little bit about how Mach's number has an effect on drag. And this is mostly to talk about what causes drag when we're in certain Mach regimes. So if we remember, Mach's number is all talking about where we are in relation to the local speed of sound. And so typically in aerodynamics kind of things, we're looking at three separate regimes of the way the fluid behaves. The first is what we call subsonic incompressible. Now this is when we're flying slow enough that the fluid can get out of the way, and it's all about how we can treat the fluid. And obviously we're treating it as incompressible, which means that we don't have to worry about density changes. This is basically everything we've done in the class. And this is really anything with a Mach number of less than 0.3. And in fact, as you're looking at it, Reynolds number is more important to what's going on than Mach number in this situation. Because the only importance that Mach number has is telling you, okay, we are less than 0.3. The other subsonic regime that we have is the subsonic compressible. And that's when we're moving fast enough we start to compress the fluid. And if you remember, that's how we're going to create a shock wave, is with compressed fluid. So that's anything from a Mach number of 0.3 to a Mach number of 1. Now, this is once again, the Reynolds number is very important in this regime. Mach number is kind of important in this regime just basically because we're locked in between 0.3 and 1. And then the last regime is the supersonic, and this is where we are above Mach of 1. And this one's important because when we break the sound barrier and we have those shock waves, the shock waves really remove any of the Reynolds number importance on drag, because it's all at this point talking about the Mach number. But shock waves are a great source of drag, and they can't exist in a subsonic flow. Now, because of this entire idea, you will notice that supersonic airfoils look a lot different than subsonic ones. And this is something that you're going to see exclusively in flight aircraft instead of watercraft, because you really don't break the sound barrier, at least right now, you don't break the sound barrier underwater. So this is something that we're worrying about with things that fly. And so if we look at like the SR-71 here, and we look at, I think that's an F-15, you'll notice that right along these edges here, these are very sharp. And you're not really going to see it in that color. Let's go to the highlight. You'll notice that the wing edges are sharp. The entire SR-71 is sharp. And that's so we can cut through the wind. It's so, not really the wind, sorry, the air. And it's so that we can shed those shock waves as efficiently as possible. So there's a strength of materials and a fluids edge going on there. And then if we look at, this is the 787 Dreamliner, one of Boeing's new planes. You'll notice that in any commercial jet, you look at the front of the wings, they're very blunt. They're very fat. You got this big fat nose. That is because this is not meant to fly supersonically, and so it needs to distribute the fluid around it in a different way to be the most efficient that it can. If we had time, there's stuff that we could talk about, what's going on with these little winglets and induced drag and all that, but this is just the end of the class, just kind of wrapping up. So if I look at a cross-section of my airfoils, you'll notice that not only are they sharp-edged, but they have a different kind of cross-section. So our subsonic airfoils that we looked at have this elongated teardrop shape, and as the Mach number goes up, the coefficient of drag is going to go up on this airfoil. That's just the way it's put together. Now, supersonic airfoils have more of this diamond cross-section, and once again, if you think about it, you got those shock waves, this is a good way to peel them off, cut through the air, peel off the shock wave. Its maximum coefficient of drag is going to be around Mach 1. And then once we get above Mach 1, the coefficient drag is actually going to start to tail down for this kind of wing. Subsonic wing, the faster you go, the more drag that you're going to induce into the system. And so that's just a little difference of when you're looking at subsonic versus supersonic airfoils and drag.